Alright guys, like just started flashing, I don't know, maybe you had some silence there. Today you're going to be learning about partial fractions, another technique that your AED friends do not have to learn. We've often simplified expressions like this, have we, by getting a common denominator and then combining the two fractions into one. So in this case, to go that way, you'd be like, okay, it's just like with normal fractions, what does this need to look like that? How can I get the same denominator? Oh! X minus 3, x minus 3, and then I'll just write this in black because it was there already. X minus 4 minus, and what did this guy need? This guy needed an x minus 4, buddy. What? And then once we did all that, we notice now they have the same denominator, so I can just subtract the whole top. I don't know how much louder that volume gets for you. I'm so sorry if you're listening to this in headphones. I guess I won't do that too much. The whole top, though, that is important. I mean, look. A few eardrum hairs are not too important in the big scheme of things. Like versus all of calculus, come on, it's not even a competition. And hopefully you were all smart enough to see, oh, it's minus x plus 4. Mr. Leven, can't you simplify the bottom? I don't want to foil right now. This whole day is going to be about unfoiling, or, as the more literate among you call it, factoring. And so this fraction and that fraction are the same fraction. Well, this difference of fractions is the same as this. The idea is this guy was hard to integrate. This guy is easier to integrate. So you're going to leverage your pre-calculus knowledge in order to go from this to that so that you can integrate both of these. All right. Without further ado, problem 1. Okay, I don't know why Mr. Leven just wasted all my time talking about this when I start out with something that looks like that. Well, surely many of you know that this whole denominator can be factored. It can, yes. X minus 3 and x minus 4. And that's why I don't want to spoil it, guys. Okay? So we're going to do a partial fraction decomposition. I'm sure you could find YouTube videos on that if you want to go in depth. But let's see what this knocks off. So the partial fraction decomposition starts off with this. I say 1 over x minus 3 times x minus 4 is equal to a over x minus 3 plus b over x minus 4. And then I'm going to clear the denominators. How can I clear the denominators here? I multiply the whole thing by x minus 3 times x minus 4. I'm not going to show this step out ever again today. So please make sure you understand what I mean when I'm saying I'm multiplying the entire equation by this. So over here kills the denominator, both of them. Here it'll kill that and leave a factor of x minus 4. I don't know how I want to write this. Let's write it out for once. What can it hurt? Maybe some of you will understand what I'm talking about for once. And maybe others will be like, oh wow, it's the first time I ever learned how to do partial fractions. I don't know. Because when I'm multiplying in the top. Yeah. And now you might see what we're doing. It's pretty special. It's pretty cool. I'm not going to lie. It's very cool. Tell your friends that this X day, whatever day it is for you, you learn how to do partial fraction integrals. They'll be like, wow. I'm impressed. the more sincere of your friends will say, I am very proud of you, fellow friend, because you are doing something that's pretty awesome. Which is to say, learning calculus in high school. Not just any calculus, the second year of calculus, or the second semester. Alright, so, I didn't cross them out. Bam, 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 bam. Everyone see how I got to here? Like I said, never doing that again. Okay, cancel, cancel, cancel. Alright, now, most of your teachers teach you some, I don't know, system of equation way of doing it. That's okay. But if you want to get good, if you want to get really good, watch this. We're going to try x equals 4. When I have x equals 4, 1 equals a times 0 plus b times 1. A times 0 is 0, and b times 1 is b, so 1 equals 0 plus b, b equals 1. And we can also similarly try x equals 3. To get the equation 1 equals a times 3 minus 4, negative 1, plus b times 0. 1 equals negative a plus 0, or a equals negative 1. I'm going to shrink all that while you're still thinking about it. The big idea is we want to make sure these two numbers are not randomly picked. It would still work out if they were randomly picked, but not nearly as nice. The idea of this selection was we picked 4 because we knew it would cancel out this. We picked 3 because I knew it would cancel out this. And now we have our partial fraction solution with very little work. I mean, very little algebraic work. So, I'm going to shrink it some more. Again, if you want to see it unshrunk, you can reverse the video. Alright, so what that enables me to do is to write this integral as this integral. We said a was negative 1 over x minus 3 plus b was 1 over x minus 4. Do you see? Do you see the power of what we've unleashed? No. Like this. Okay, just to be clear. Alright, and now I can integrate both of these easily. What? Yes. Yes, you can. This guy, the bottom, its derivative is easy to get. In fact, its derivative is 1. So when the bottom's derivative is right on the top, it's a natural log integral. But don't forget about that negative sign. The bottom's derivative is 1. This is a natural log integral also. So I took this seemingly crazy integral and made it quite easy to get. Quite easy if I do say so myself. That's all. That's all there is to it. Loggy log. Nice and easy. Short and sweet. And that's how these problems go. So, without further ado, more. Ooh, ugly or top? Doesn't matter. Not really. Let's find out. Alright, so on the side, I'm going to do it all over here this time. Hopefully you can integrate, or sorry, not integrate. Not integrate yet. X minus 3. X minus plus 1. Whew, that was a close one. I'm talking about factoring, guys. We're talking about factoring. Alright. So, the partial fraction decomposition I'm talking about is 5x minus 3 over x minus 3 times x plus 1 equals a over whichever one you like, it doesn't really matter, plus b over x plus 1. Bueno? Beautiful. Great. When I clear the denominators, and this is what I was talking about, I'm not going to write it again, I'm multiplying the entire equation by this. So they kind of switch over here. And again, they're not random numbers. I'm going to try... What would kill this? X equals negative 1. That sure would. I get 5 times negative 1 minus 3 equals a times 0 plus b times negative 4. Okay. This whole thing is negative 8. B times negative 4. So b equals 2. Huzzah! I don't know if I said negative 2. 2. Definitely 2. My bad. I said 2. I don't know what I said. Alright, and then, what would kill this? 3. Very good. Try 3. 5 por 3 menos 3 igual a por 4 cuatro más b por 0. 15 minus 3 is 12. A equals... Wow. It's so fun. Like, I literally can't believe how fun partial fractions is to me. I don't know if I ever told you guys this in class yet. Again, you could be watching this at any point in the future, really. But the first thing that got me jazzed up about math was factoring. And, well, as you can see, this is like factoring the next level. I do love polynomials, man. It's crazy. I'm crazy, but, you know. That's just me. Okay, 3 over x minus 3. Because a was the one on top of x minus 3, guys. See? Okay, I'm not just making this up. Plus, come on, b over x plus 1. Yes. Now, on the last one, I rushed over the integration. I mean, if you're having trouble with logs still, you gotta fix that. But it's these two logs integrals. See if you can understand how I could decompose this to this in my head even. Because this is the reason I'm not writing it out every time. Because this is what my brain's doing for me. I see it like this. This is 3 times a log thingy. This is 2 times a log thingy. And both of these integrals are easy to get. Why? Because again, the entire derivative is bottom. The derivative of the entire bottom is 1. The derivative of the entire bottom is 1. The entire bottom's derivative is on the top. Natural log, kiddos. Beautiful, sensual, natural logs. Sorry if you threw up. I kind of threw up saying it. Anyway, done. But you see, people, do I really need these absolute value bars? Do I really need these absolute value bars? Yes, you need this. No, you don't need these because of the 2. The 2 is kind of like squaring everything. I don't know. Technically you do. Technically you need them. I would always leave them. Don't make this decision. All right, and that's partial fractions. Happy as a clam. All right. So this one. Now, these last two, we had an issue where that log trick doesn't work. What's the derivative of the bottom? 2x. That's not on top. Nor can you make it on top. But I'm always checking that because I'd like to be able to use that rule. That rule's pretty sweet when it works out. What's the derivative of the bottom? 2x minus 2? That's not on top. It's really hard to get that on top, actually. So I do all this, and then look, it works out. It's not bad. It's pretty fast once you get good at this. What's the derivative of the bottom? 2x minus 2, you say? Oh my goodness gracious. That whole thing is a hook-off. That whole thing is u prime. For u equals the whole bottom. And again, I would never ever write this down. I'm writing it down for you. So this whole integral is this. Nope, sorry. Is this. Ba-boom. Done. No work. Would natural log work? Sorry, would partial fractions work? Yes, partial fraction would also work. But partial fractions is a lot more time than this. So we're always looking for this way out, guys. We are always looking for this nice way out. Alright. Uno mas. Well, no, not really uno mas, but... Well, you'll see. Sorry, I'm still getting over a cold. So I look at this. Some of you already started factoring the bottom. The bottom does factor, but there's a bigger problem. What's that bigger problem, guys? What? Do you not notice it? This is something we've done in AB. Are you checking this? Because you need to be checking this in every problem with polynomials like this. The degree of the top is 3. The highest power in the top is 3. The highest power in the bottom, 2. The highest power on top, power, highest power. On top, bigger than high power on bottom, highest power. I don't know what you guys are doing when you study this, but let's just make sure we're all reading correctly. Highest in both cases. Not high, just highest. Versus highest power on bottom. And I could even say or equal means long division. We just practiced this in 6.2, and now it's 6.4. Time sure is flying. For me, I'm recording these all. I mean, you can look at the time stamps and figure it out. Highest power on top is bigger than highest power on the bottom. We're going to long divide. Top dog in the dog house. Bottom dog outside the dog house. Let's use blue for contrast. All right. Ask yourself, how can I make the higher power here match the higher power there? If you said or thought you can do that by multiplying by x, you would be correct. we're going to multiply these by x. We're going to multiply this whole polynomial by x to make them matchy-matchy. X. And I put the x above the x place, and that's just a weird thing we do. Okay. Actually, in fact, let's think ahead. We usually want to write a long division like this because there might have to be an x squared place, and there will in this case. Spoiler alert. Okay, now it makes more sense. Sorry. All that stuff I said before. So one more time. How can I make this guy match the frontmost thing? I multiply by x. X times x squared is x cubed. Matchy. X times x is x squared. And that's why I wanted to plan ahead by having that 0 there. X times -2, -2x. And, of course, I'm subtracting this whole kit and caboodle. Don't forget to subtract. Don't forget to subtract the entire group, because at this point, you're going to get something important. -x cubed minus x cubed, 0. 0x squared minus x squared is -x squared, and that's what everyone forgets. It's never negative when I check their answers. And then negative x minus -2x. And of course, you want to carry down the 2. Okay? Now, I want to make sure this whole thing matches that whole thing. Mostly, I want to make sure the front matches this front. So what do I multiply to get x squared to match -x squared? I multiply by -1. -x squared, matchy, -x, no matchy, +2, matchy. Again, people, ladies and gentlemen, boys and girls, we are subtracting the whole entire thing. I don't know. New color. My phone is going crazy. I don't know what's happening. Sorry. Purple. Negative x squared would be positive x squared. Cancel. Put 0 there just to keep a placeholder. Positive x minus negative x is positive dos x. Positive 2 minus 2. Now we have this. And now for the first time, this guy's degree, the highest power here, is lower than the highest power here. That's one sign you're done. The other sign you're done is there's no way you can multiply x squared by something to get 2x. Nothing nice. Don't be smart. Okay. Yeah, there you go. Math teacher telling you not to be smart. Dad, today my math teacher said, don't be smart. Remainder. Okay, I'm talking about remainder. I don't know if you know these notations. Okay, so the remainder is this. So plus 2x sobre x squared x minus dos. Okay? So this integral is equal to that whole integral, and I know, your life's so hard. I'm so sorry you had to do all that. Long division, you know. It's tough. But it's almost over now. Okay. A tutoring client is like going crazy trying to contact me. I'll have to stop recording in a minute. But I don't really care because I still have so much time. Alright. Equals. Again, what we just did was prove that this whole thing is that. X minus 1 plus and now the getting's good. The getting is real nice. Okay, guys? This guy, beautiful. I'm sure most of you have already integrated in your head. That guy, beautiful. Most of you already integrated in your head. Is this guy a log? Let's check. 2x plus 1. Oh no. If you pause this computer and throw it out the window, I mean, that's your loss. I'm pretty upset too. I had no idea this would happen this way. This guy needs to be done with partial fractions. And again, in case you're all misunderstanding me, we couldn't have done partial fractions in the start. Partial fractions requires, I'll write it down here as a note, you need proper, this will sound nice, proper fraction to do partial fractions. Okay. Yikes, that was ugly. I should have just... Okay? So I had to do all this, okay? It wasn't wasting your time. Maybe I could have let you know sooner that this was happening, so you're all not crying horribly. It's okay. It'll be okay. I got your back, guys. I can factor this pretty well. Plus 2, x minus 1. Yeah? You all get that? Let me look at my notes. Yeah. I'm pretty cool. A over x plus 2. Yeah. I know. Most of you don't even probably watching this like 10 minutes later, just so you could stop screaming at the computer. I would. I'd be upset. Clear the denominators. Denominatorinos. X equals 1 will give us the equation 2 equals a times 0 plus b times 3. Or b equals 2/3. Now don't just copy this. Make sure you understand how I go from here to here to here. Because obviously this is a very huge part of what we're doing. Negative 2 would kill this. Yeah? I'm going to shrink everything, alright? And I'll walk you through what we've done so far again, just to make it up to you about how awful everything is. This is going to go off screen, okay? Say bye-bye. And that is 2. Because I'm just going to rewrite the pink thing. Off the top of my head, that seems risky. Probably going to mess this up. X minus 1 plus 2x over x squared plus x minus 2. And now this green part, let me do this. Okay, I'm just going to write it all in one integral just to make it look maximally cool. Right? If you want to impress your friends, you show them a really long expression. Like this. I mean, even your friends in pre-cal would be impressed by, hey guys, you want to know what's something interesting? That fraction equals this. Like you memorize that, and you go out on the streets or at lunch, and you show people what you can do. Man, you guys are going to be so popular. Bam! So that whole thing is this whole thing. 4/3, because A is 4/3. A is above x plus 2, okay? Don't do anything crazy. Don't do anything I wouldn't do. Alright, now let's integrate this. Oh, feeling strong? Feeling good? X squared over 2. X. This is a natural log thing. Gotta start seeing it as a natural log thing. The derivative of the bottom is 1. 1's always on top. Derivative of the bottom is 1. 1 is always on top. Anytime the derivative of the bottom is 1, you got this, guys. What? I have to say that was pretty cool. I mean, I don't know. I'm just sitting here thinking. I think I'm pretty cool though. Okay? It's not so bad. Lots of steps. You won't see a lot of these. Okay? You'll see a lot of these on your homeworks, which you need to be doing. But you won't see a lot of these on the test because it takes a lot of time. But this is letting you practice your long division skills and your impartial. Your long division skills and your partial fraction decomposition skills, both of which are important skills to master for integration. Okay. Here's a nice cool down. I'm not going to do a lot of dead time on the video, obviously. I would suggest you pause this after I finish talking. I'll tell you when to pause it. These are 4 integrals that at this point look very similar to one another, but each require different integration techniques, or at least 3. 2 of them will be the same. I wonder which 2. I would say pause it. Give yourself, I don't know, 4 to 8 minutes. 4 if you're really fast, 8 if you still need some work. And try to do each of these integrals before you continue on. 3, 2, 1, okay. I'm going to start doing it. I'm based on, like, when I asked you guys to do homework on a weekend, I don't know how many of you did it. This guy is the formula for arctan. So that's why we memorize things like the non-chain rule version. Because I can recognize that as plain as the nose on your face. You know, the nose on my face is not that plain. I don't know. I mean, but by that I mean, like, you know, how often do you stare at yourself in the mirror? I'm pretty vain, but I don't stare at myself that much. Derivative of the bottom. 1. It's on the top already. But bam! I can't remember what the BC kids did when we did this in class. The derivative of the bottom here is 2x. That's not on top. You're going to look for something else. Square plus a square, arctan. Now, that should have been a spoiler for this one. Derivative of the bottom is what? 2x? Can I get that on top? I sure can. I said, oh, I know, I did it with orange. I sure can by multiplying by 1/2. So these two are the same. That means this requires something else. Are you excited? Did you get these 3 right? I'm pretty proud of you got these 3 right. This one may have been the hardest one for you because you've been working with it the longest, and you all hate this one based on my anecdotal evidence. Oh! It's a group to a power. What's the derivative of the inside of the group? 1. Is there 1 to hook up? Yep, always. Add 1 to the power. Divide by the new power. Plus C. Did I add plus C all of them? Yep, I did. Boom! Done. Cool? Cool. Bodacious. Excellent. Now you may have looked at these 2 directions and seen them as similar. Now, I believe we did these in class because BC is a little different than AB, but again, go ahead, pause this video. Give yourself anywhere from 2 to 4 minutes. 2 if you're doing well. 4 if you're doing not so well. Pause it, try these integrals, and come back in 2 to 4 minutes. Okay. I'm assuming you unpaused it now. 3, 2, 1. In this case, in both of these cases really, you have a natural log inside. When you have a natural log inside, you're worried about this relationship. You need to have something to unhook. And in both of these cases, you have that to unhook. right? You have a 1 over x to unhook. So in both of these cases, it's about understanding what's going on. In both of these cases, it's about understanding how it's going to get unhooked and which rule it looks like after that transformation is done. In case A, we have an integral dx. Oh, we did it this way. How will I write it? 1 over natural log x times 1 over x times dx. Now, some of you might be thinking, reverse power rule, let's just do the reverse power rule. That's a power to the -1. -1 is not a reverse power rule. -1 is a log rule, usually. Again, if you're having trouble seeing this, the bottom, the derivative of the entire bottom is right here. I could even write this like this. Although I'm sure most of you would be sad to see this happen and would not be able to write this successfully. The derivative of the bottom is on top. So we're talking about natural log absolute value of the bottom plus c. Okay? Hard problem. Not impossible. Why not parts? If any of you tried parts here, parts is always a product on the top. Parts is never like a fraction looking thing. Fraction looking things is kind of the point of this whole lesson. But fraction looking things are the domain of logs, arctan, arcsine, partial fractions. Yeah, I think I said that right. Here, I have something times its derivative times dx. In fact, I can write this really leadingly. I don't know if that's an adjective. Adverb? Adverb. With a power. So I see a group to a power times the derivative of the inside of the group. Add 1 to the power, divide by the new power. These two are some of the more trickier problems you'll ever see. But they're doable. It just requires that you trust yourself enough to play with it. They require time. If I saw those problems on the test myself, I might even consider like leaving them blank. I probably wouldn't. I know these ones enough because I teach these problems. I teach these problems because they're tricky. But if I was in your shoes on the test day and I saw something like that and I thought about it for 2 seconds and I couldn't think of how to integrate it, I might skip. I might come back. It's okay. You guys got to get good at skip. All right. Well, again, I'm very proud of you if at this point you've done 6-2, you've done 6-3, you've done 6-4, and you've done all the assignments. If you haven't done all the assignments, you have not learned the material. Watch 6-2 again. Like, I don't know, 6-2 is hard. 6-3 is confusing, 6-4 is confusing. Like, they have confusing bits. Watch them again, but make sure you're doing the homework. If you're not doing the homework, you are nowhere near capable for the BC test. So please do the homework. Again, I'm very proud of you guys for learning math on your own. Good job. Keep up the hard work. Have a nice day. Talk to you sometime. Tomorrow, in a minute, if you load up another video. Whatever. Whenever you want to talk to me, you can always load up these videos, I guess. Or whenever you want to hear from me, I can't talk to you. Unless you're hearing me in your head, in which case, I don't know, that's pretty crazy. Anyway, have a nice day. Bye-bye.